Dependency Inversion Principle, DIP, the D in solid. Ever had a piece of code that crumbles every time you add a new feature? That's because your high-level logic is chained to the low-level details. Today, let's break those chains with the Dependency Inversion Principle, the D in solid. The core idea, the dependency. Inversion principle says, high-level modules should not depend on low-level modules. Both should depend on abstractions. In simple words, your business logic should depend on contracts, not concrete implementations. This keeps your software flexible and easy to extend. Let's look at how things go wrong first. Imagine a simple app where an email service sends notifications. Your main notification manager class directly creates and calls the email service. At first, it works fine. But one day, your boss says, "Hey, we need to add SMS notifications too." Now, you're tangled in refactoring, adding conditions, new methods, and chaos everywhere. Why? Because your high-level module, Notification Manager, depends directly on a low-level one, email service. That's a dependency inversion violation. What's happening here? Tight coupling. The Notification Manager is hardwired to email service. That means if you ever need to switch to another notification method, like SMS, push notification, or Slack, you have to open and modify the Notification Manager class itself. Every new feature means editing core logic. That's a fragile design. It's like rebuilding the foundation every time you add a new flow. 2. No flexibility or extensibility. What if your app later needs to send notifications through multiple channels? You can't reuse the notification. Manager ISIS. It's glued to email service. 3. Hard to test. Because the manager creates its own dependency, you can't easily substitute a fake or mock service during unit testing. Your tests will always try to send real emails. Not ideal. The fix? Introduce an abstraction layer. Define an interface, say iNotification service, with a method like send message. Now both email service and SMS service implement the iNotification service interface. Your notification manager doesn't care how notifications are sent, only that they can be. Suddenly, adding a new push notification service becomes plug and play. Think of it like your laptop charger. Your device doesn't care how electricity is generated, solar, wind, or coal. It just needs a standard plug. That plug is your abstraction. The same principle applies to clean code. Why it matters? 1. High-level code is now independent. The notification manager doesn't care how messages are sent. You could add a push notification service, Slack notifier, or even a WhatsApp notifier tomorrow, and the manager will happily work with them. No edits needed. Plug-and-play architecture. The interface acts like a socket. You can plug in any compatible notifier without touching the high-level business rules. This is how modern dependency injection frameworks work. They just connect the right plugs at runtime. 3. Testability. Because notification manager depends only on the interface, you can easily pass in a fake notifier for unit tests. No real emails, no side effects, just pure, predictable testing. 4. Future-proof design. When your system depends on abstractions, it becomes immune to change. Technology evolves. APIs deprecate, services change. But your high-level code remains untouched. You just swap out the concrete class. That's the D in solid, your safeguard against rigid and breakable code. It keeps your architecture clean, flexible, and future-ready. I'm Ashish Kumar. Thanks for watching. Remember, high-level modules shouldn't depend on low-level details. Both should depend on abstractions.